All right, today we're going to talk about perpendicular lines and how they relate to parallel. So how we can kind of get perpendicular from parallel and parallel from perpendicular, and then talk a couple proof type problems determining when we have parallel and perpendicular lines. So we're going to start with a couple of vocabulary terms. Distance. Now we've talked about distance in the past. So distance between 2 points, and we had a distance formula, which we're going to come back and visit here in a second. But when we talk about distance from a point to a line, it's a little bit different. So from one point to another, there's only one way to go from one point to another point. But if I want to go from a point to a line, there's lots of different ways I could go. I could go from point A down to line K here, or I could go from point A to here. I could go from point A to here. So there's lots of different options there. Now, when we talk about the actual distance, so when we use the term distance from the point to the line, we're talking about the length of the perpendicular segment. So when I come straight to line K, and we see that I have that right angle right there. So that perpendicular distance, or that perpendicular line, represents the distance from that point to the line. It's the shortest distance. So if I try to go from A to any other point on K, I'm going to travel a longer distance. So A to B is shorter than A to C here. It's shorter than A to D. So that perpendicular line represents the shortest distance from one point to that particular line. And that's going to be important because when you are asked to find distance, so what is the distance from point A to line BD? So we want to start at point A over here, and we want to get to line BD right here. So there's 3 different paths. I've got a path that I'm going to highlight in orange from A to B. I've got a path that I'm going to highlight in green from A to C, and then a path that I'm going to highlight in blue from A to D. Now I've got 3 different paths to travel from point A to line BD, but they're asking about the distance. So the distance is the one that has that perpendicular symbol. They have to be perpendicular to one another. So I want to travel from point A to point C. So when I want to calculate distance here, I'm going to calculate the length from A to C. And so using my formula, I'm going to use my x values. So -3 minus 1. So here's one x, here's the other x. And that's squared. And then I'm going to take my y from one minus the y from the other. So 3 minus -1 squared. And so then from here we can reduce this down. -3 minus 1 is -4, squared is 16. 3 plus 1 is 4, squared is 16. And so we get the square root of 32, which you could plug into your calculators and get some decimal answer. But when you're picking out distance from a point to a line, the big thing here is make sure you pick that perpendicular segment. And then from there, it's just distance formula, x minus x plus y minus y, square them both, add them, square root. So always pick the perpendicular. A theorem we're going to need to know here, and this is one we've discussed in class before, so this is not like a new concept, but now we're just kind of formalizing it. So if 2 lines intersect to form a linear pair, so remember a linear pair means add to 180. Okay, so we're going to add to 180, and if they tell us that those 2 angles are congruent, so basically what we see in this picture here is that the measure of angle 1 plus the measure of angle 2 is 180 because they're a linear pair, but now they're saying 1 and 2 are exactly the same. Well, then the only way that can happen is if both angle 1 and angle 2 are 90 degrees to get that 180. So that what we're saying is that angle 1 must be a right angle, angle 2 must be a right angle. So when you see that situation where like one side's right angle, the other side must also be. Or if they give you that they're a linear pair and that they're congruent, they have to be right angles. Now the ones that we're going to be using primarily for this section and on the test are going to be ones like this one here. So the lines perpendicular to a transversal theorem. Long name for a theorem, you don't need to know the name of it. All you need to be able to do is tell me how you know something's going on. So what this theorem says is in a plane, if 2 lines are perpendicular to the same line, so right here we have line M and line N, and they're both perpendicular to line L. So because they're both perpendicular to line L, we automatically know that line M is going to be parallel to line N. And we could prove that a couple of different ways. If they're both perpendicular, that means that this is a 90-degree angle, and that means this is a 90-degree angle. Well, if that's the case, that means that these corresponding angles are congruent, which makes my lines parallel. So M and N must be parallel because of corresponding angles. Now, if you were working on a problem like this, and they ask which lines are parallel in the picture, well, M is parallel to N. How do we know that? All you have to do here is just say they're both perpendicular to L. You don't have to have a long drawn-out explanation. You don't have to have the name of the theorem itself. It's just, I know M and N are parallel because they're both perpendicular to a different line. So they're both parallel, they're both perpendicular to line L. Okay. The next one, the perpendicular transversal theorem, again, not a name you need to remember, but in this theorem, we've got two lines that are parallel, so we see these little markings here that are telling us parallel, and then one line is perpendicular to the other. So if we give these some names, call them like A, B, and C. So right now what we know is that B is parallel to C, and we know that A is perpendicular to B. Now, if these two lines are parallel, so if B and C are parallel here, that means that corresponding angles have to be congruent. So then if this angle up here is a right angle, this angle must also be a right angle. And so what happens is this tells me A is perpendicular to C. So because I had parallel lines, and one was perpendicular to the other, or one line was perpendicular to one of the parallel lines, it has to be perpendicular to the other. And you could use this perpendicular transversal theorem, you could use corresponding angles to make sure that you get the right angle and then definition of perpendicular. But basically all you need to do is tell me that they're perpendicular based on this theorem here. So an example of what you might see with this, it says determine which streets, if any, must be parallel in the diagram. So we're trying to find parallel lines in this picture here. So as we're looking at the map here, we have some things to take note of. So we have this right angle, and this right angle. Now, what we're trying to figure out here is which lines are parallel based on that information. So what you're looking for is, are there any lines that are perpendicular to the same line? So for instance, Pacific Street here. So Pacific Street up top here is perpendicular to 144th. And then Center is also perpendicular to 144th. So because Pacific and Center are both perpendicular to 144th, we can say Pacific is parallel to Center. And my reasoning would be they're both perpendicular to 144th. Okay. So then we look for other things that might happen within the picture here. So again, we kind of take note of the right angles. I have a right angle here matched up with a right angle here. So that means I've got 144th Street perpendicular to Center, and I've got 132nd perpendicular to Center. So because they're both perpendicular to Center, I can say 144th is perpendicular to 132nd. Both are perpendicular to Center. Okay, so now if we're looking at this, a couple other things we would be able to say. At this point, because I have Pacific and Center parallel, and because I have 144th and 132nd parallel, I would be able to say that 132nd and Pacific are both perpendicular. And that's coming from like corresponding angles, either here or same side interior coming in here. So I can say that those are perpendicular. Now, the one thing I cannot do is I cannot say anything about 114th Street over here, because it doesn't have any right angles. It has nothing relating to itself to any of the other streets. So there's nothing I can say about 114th, even though it's marked in the picture. So Pacific and Center would be parallel, 144th and 132nd would be parallel. That's all we can say for this particular scenario. Another example, very similar to the first. So we have our different lines here, A, B, C, and D. It wants to know, is B parallel to A? So for question number 1, we'll label it. So for question number 1, they want to know, is A parallel to B here? So let's take a look. So A and B are what we're focusing on. So in order for A and B to be parallel, we would need them to be perpendicular to the exact same line. So if I look here, I see A is perpendicular to C, but I don't have anything about B and C. So that's not going to work. So then if I look again at the other line here, A is perpendicular to D, and B is perpendicular to D. Well, that helps me. So in that case, is B parallel to A? My answer would be yes. The explanation is they're both perpendicular to D. So because they're both perpendicular to the exact same line, they have to be parallel to each other. And so what that tells us then is that this line here is parallel to this line here. And so now when we go to question 2, it says, is B perpendicular to C? So for question 2, can I say that B is perpendicular, I'll do this way, is perpendicular to C? Well, since I just said A and B are parallel, that means corresponding angles must be congruent. So if this right angle here exists, then that means this angle right here must exist as a right angle. And so if they have the right angle there, that tells us that yes, B is perpendicular to C. And as far as an explanation, because A is parallel to B and A is perpendicular to C. So because they're parallel and A is perpendicular to C, B must also be perpendicular to C. Okay, so you don't have to have long drawn out explanations. All you have to do is just basically tell me what you see in the picture that tells you that that's the case. Okay. Last thing here, just a quick proof. It says prove the perpendicular transversal theorem. So given line H is parallel to line K, and given that J is perpendicular to H, prove that J is perpendicular to K. So we're saying these two lines are parallel, H and K, and they're telling us that H and J are perpendicular to one another. So that's the information they're telling us right off the bat, okay? So for step 1, we know H is parallel to K and J is perpendicular to H because that's given. Okay, now from there, as we kind of go through this proof here, step number 2 says, well, the measure of angle 2 must be 90 degrees. Well, so if I'm looking at angle 2 right there, the reason I know that it's 90 degrees, I can use a couple different things here, but that's like the definition of a right angle or definition of perpendicular. So I'm going to say definition of perpendicular. Since I told myself it was perpendicular up in the given, the definition is that I make right angles. So the next thing, they're telling me that angle 2 and angle 6 are congruent to one another. So they're saying that this angle 2 here is congruent to angle 6 here. Now the reason we know that, H and K being parallel, means that those are corresponding angles. And so they have to be congruent to one another. And so then the measure of angle 6 must be 90, because if 2 is 90 and 2 is equal to 6, then by substitution or by transitive, I know angle 6 must also be 90. And then for step 5, that means J and K are perpendicular because that's definition of perpendicular. So again, we're using things like the corresponding angles or the alternate interior-exterior angles. We're using substitution and transitive. So it's a lot like the proofs that we had in the previous sections, but now we're just talking about perpendicular rather than just parallel. So with that, you guys should be able to work on the assignment for today, which is a worksheet. So you need to either get that in class or get it off the Google Classroom. You need to make sure you ask questions if you're having trouble with any of the problems, so either email or ask in class, or make sure you check the answer key when that comes out on Google Classroom as well. Okay, so after that, should be good to go.